Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to our lecturer Dr. Azizul and friends. Today I would like to talk about energy balance mini project. Topic is production of 59,400 MTA of vinyl chloride through acetylene and hydrogen chloride. So overall of the process solutions, since we learned about the energy balance, we have to understand the question given, soft mass balance, construct table of properties needed, and lastly soft energy balance. So this is the overall process flow diagram of vinyl chloride, which involves jet mixer, reactor, cooler, and lastly distillation column. This is process info from the question given. On jet mixer, acetylene and dry hydrogen chloride is mixed in 1:1 molar ratio. Then mixture is cooled from 25 to negative 80 degrees C in 1 atm. The cool mixture is then passed through a tubular reactor unit. To solve the mass balance, choose the subsystem, draw PFD, construct DOF, state the basis, process specification, state known, stream in mass flow rate, and lastly write and solve mass balance equation. To solve the mass balance, draw like this and state the basis. If basis not state, we have to assume. I assume 100 kmol per hour of acetylene to jet mixer. So from the DOF I got 0, so problem is solvable. And then goes to process specification. So our mass balance, since 1:1 molar ratio, so if I assume acetylene 100, so H2 stream 2 is HCl in stream 2 also 100, so outlet must be 200 kmol per hour. And then state the composition. I got 0.5, seems to hydrochloric acid. And then to solve the energy balance, we must derive formula and simplify it. Then list the reference state, construct table to know enthalpy and energy. To calculate the energy balance, okay, we draw PFT and then follow this step. Scale up molar flow rate. Okay, as we know that we just assume 100, so we have to know the exactly feed flow rate. So from the basis calculation of feed molar flow rate is 100 kmol per hour for both acetylene and HCl. The amount of VCl produced is 6,997 kilogram per hour. So the ratio is I have to use ratio of VCl produced equal to actual amount over calculate amount. So I got the ratio. Then the ratio must time to the calculate amount. I got the actual, which is 107.2 kmol per hour. Then calculate the energy balance on jet mixer. So I draw the general energy balance. Reference states, substance C2H2 and HCl in vapor. So temperature is 0. Temperature of reference is 0 degrees C at 1 atm. So draw the hypopath and refer to table B2, put the value and calculate. H1 I got 1.104 kg per mole. Same goes to H2. Same calculation method used for stream 1, H3, H4, and then lastly calculate the energy, which is Q equal to molar flow rate times.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rohaizam bin Alwi. I want to present about the reactor. Okay, process fact on reactor. The temperature in reactor gradually raise to 200 degrees C as the catalyst deteriorates. The pressure maintain 1 atm. The effluent gases contain vinyl chloride along with unreacted acetylene and hydrogen chloride. The conversion of acetylene is 95%. The reaction takes place in vapor phase and is exothermic nature. Calculate mass balance on reactor. This is a process flow diagram. Stream 3 is inlet for reactor and stream 4 is outlet reactor. For molar flow rate, inlet is 200 kilomole per hour and M4 is unknown. For molar fraction for acetylene is 0.5 and molar fraction for hydrogen chloride is 0.5. For outlet reactor, for molar fraction for acetylene is 0.05. Hydrogen chloride is unknown and vinyl chloride is 0.95. Overall mass balance input minus output minus consumption equal accumulation. Process application of reactor. 1 mole of acetylene reacts with 1 mole of hydrogen chloride will be produce 1 mole of vinyl chloride. Using stoichiometric coefficient from the chemical equation, we got 3 equation for and 4 for acetylene, hydrogen chloride and vinyl chloride. Provided that 95% conversion of acetylene equal 5% of acetylene is remain in the stream 4. We got the answer X equal 95. Substitute X into the rest of the equation will determine the amount of SCl and VCl in stream 4. We got SCl equal 5 kilomole per hour and VCl equal 95 kilomole per hour. This is the summary of chemical compound flow rate based the calculation before this. Next, we go to solving energy balance. The stream 3 is inlet reactor, stream 4 is outlet reactor. The pressure 1 atm in inlet, temperature is minus 80 degrees C. At outlet, pressure 1 atm and temperature is 200 degrees C. Okay, for the molar flow rate in and molar flow rate out, we calculate use the ratio of targeted production rate over calculated production rate. For the enthalpy in and enthalpy out, we calculate use table CPDT, table B2. And for enthalpy formation, we got from the table B1. Okay, the energy balance around reactor. The above enthalpy is calculated using the same formula as above for stream 3. For stream 4, since they are reaction, they are formation of chemical compounds by referring to the table B8. The heat of formation for each compound are used in stream 4. For Q, to find Q, we use this calculation. Q equal heat of formation plus enthalpy due to the temperature change minus total enthalpy And the final answer for Q, we got minus 1.62 million kilojoule per hour. Okay, that's all. Thank you.
Assalamualaikum, Dr. Azizul. I'm going to present about a cooler for production of 59,500 mT of vinyl chloride. Okay, so the mixture from the reactor outlet stream is pre-cooled until the operating condition. So the mixture is cooled from 200 degrees Celsius at 1 atm to 20 degrees Celsius at 1 atm. Okay, so for this for the cooler, since there is no splitting, so the mass balance from the reactor and the until it out from the cooler is same. So therefore is equal, M4 equals to M5. M4 is from the reactor, M5 is from the cooler, inlet and outlet. Okay, since from the reactor we the cooler receive 200 kilomole per hour. So to get the molar flow rates, we need to time the molar composition. So we get here for the HC acetylene we get 0.2625, hydrogen chloride 0.2625, and vinyl chloride is 0.75. Okay, this is the table for strain number 4 and 5. Okay, for the energy balance, since it's only different different temperature, so it's type 2, so we only use CPDT. For H1 and H2 we already get from the reactor, so therefore we just only want to get H3 and H4. Okay, so this is the general energy balance. Delta H and delta EP plus delta EK is equals to Q plus W. So reference state we use here 200 degrees Celsius. For the cooler we use 200 degrees Celsius and in state vapor state at 1 atm. Okay, for here this one is from table B2. This we can get this data from table B2. All the calculation is included in the words and Excel. For this one also same, only the vinyl chloride, since there is that we don't have from the book, so we just Google it and we get it 52.25. So therefore the energy balance for stream 5, this is the calculation for the CPDT. So for the heat that been transferred out is this 2170,554.42.1 kilojoule per hour. We already convert it to kilowatt in our Excel. That's all. Thank you.
To process fact, and the final answer is 0, means this question can be solved. So let's move to calculate the energy balance. Generally, there is two type in solving the energy balance using hypothetical path. Type the first one is type 2, different temperature, and type 3, phase change. Solving energy balance, for simplify the formula, state the reference state, create a table, and solve the unknown. So generally the distillation column is a open system, so we will use the delta H, not delta U. I want to highlight that in this station column there is two phase. For the top stream is in vapor phase and the bottom stream is in liquid phase. So in the table there is two phase that I state. Calculate the energy balance for H1, H2 and H3. This one is in stream 5. The enthalpy is same as condenser outlet. For H4, this one is in liquid phase. That's mean bottom stream. For C2H2, bottom stream outlet is minus 30 degrees C. So I take the the CP value from table B2 and then using integration to solve and get the enthalpy value. Same like the H5. I want to make the correction here. The phase is in liquid, not vapor. Same like here, I made the same mistake. The phase is vapor, not the phase is liquid, not vapor. I'm sorry. Here is the top stream. Quite difficult. First of all, the C2H2 in liquid phase, and then we have to calculate we have to go to negative minus 81.5 because this one is the normal boiling point for acetylene. And then after get the CP, we can go to phase change type 3 from liquid to vapor. So the H7B equal to HV. HV stated at negative 81 minus 81.5 degrees Celsius is 17.6 kJ per mole. And then type 2, we use the CP dt, and then we sum up the value and we get the answer for H7. Same like HCl at top stream, we need to go to first of all we need to go to the 85 degrees C because 85 degrees C is the normal boiling point for HCl. In order to go to 85 degrees C, we have to find the CP because it's type 2, different temperature. We need to do the CPDT, and then after we integrate, we get the value negative 3.05851 kJ per mole. The normal boiling point for HCl is 85 degrees C. I get from the table B1, and the heat of vaporization HV is 16.1 kJ per mole. And then get back to different temperature, we using the CPDT. Total up the value and convert it to kJ per mole. kg per k mol. We get the value of 15226.14. Same like this one. Just want to highlight that in the book we don't have the vinyl chloride boiling point and CP value. So we refer the website name chemeo.com, and then we calculate the energy balance, and the answer is Q is equal to minus 444.428. I think that's all. Thank you very much. Sorry, this one is the complete table of uh, enthalpy table. Thank you very much.